and also deploying a little bit embedded devices, but not really IoT plus devices. And just to give you an idea, no one would think of a Western Digital NAS box or a QNAP device or otherwise as being an IoT device, but it's certainly an embedded system running in embedded Linux, which is where busybox and things are very popular. So the first part about this is just the idea of what is, and you've seen this, so I don't have to spend a whole lot of time on it. There's a single executable file, not multiple. There's no installation required, and it uses sim linking to just change how it behaves. The other thing that's new, and we'll take a look at during the course of this talk, is what I alluded to in the previous talk, which is taking a SQLite database and turning the actual database itself into an executable package. And then finally, the traditional way of dealing with scripts is simply to write your script dot your language extension, whether it's .py or .tcl or whatever. And it happens that for TSL it's .afts. And I'll actually show the code that makes all that run as part of this discussion, since it's an interesting piece. The other thing to know about, depending on your platform, is when you have a script-based extension, how does it register? Windows is different than everybody else. No surprises. Everybody else is used to using shebang notation. But Windows actually uses something called path extension. It's in your environment variables, and it's in the system hive, which means you can't even modify that if you don't have admin privileges. And then secondly, you have to go into the registry and set some flags for which they provide convenience tools called ftype and associate. And if you are using any of the more modern versions of Windows, it's possible to have a file type associated with many different applications, much like the way the old Mac did. So there's additional registry twiddling. And that is just a quirk of Windows that's setting up what you need to do to get a file extension to be
These have to be erased, you're saying?
It's a little bit tricky.
Okay, I can.
So I want to share a little bit about the private cloud and why I think it's incredibly important. And some of this data is coming as well. I worked at Microsoft in the public cloud part, in Azure and so on.
These are
already
burnt.
over at Amazon who've tried to hire me to work in the group on stuff.
This back to fill.
But the private cloud is actually starting, what they call the edge cloud at Microsoft, is starting to become the dominant growth area. And in fact, public cloud use and its scale is declining, even though that's not been officially discussed. In my home office environment, I have 10 gigabit fiber everywhere. And 10 gigabit fiber is cheaper to run than 1 gigabit copper. So my whole house is wired with 10 gigabit fiber. All my computers, drives, everywhere, I access it at very high speed for my network drives.
Connectors are more expensive though, right?
No, that's a thing people don't understand. I can talk to people about how to set it up. 10 gigabit fiber is cheaper. It's pretty amazing. And if you don't have 10 gigabit fiber, you're probably wasting your money on NAS systems, because you're just bandwidth limited to never getting more than about 90 megabytes per second.
Thank you.
And if you're trying to run those things over a Wi-Fi network, you're really going to be unhappy. So let's talk, I'm giving a little bit about some of the IoT space, but really this plays to a lot of what happens in the private cloud, which is, I use the term mesh Wi-Fi. For anybody who's run Wi-Fi in their home and had it not be reliable, or as they get further away from the base station it degrades, you really want to be putting in mesh-based Wi-Fi. Almost every major vendor of a base station for Wi-Fi supports mesh-based. It's a very different way of delivering, and if you don't have it, you definitely should look into it. The second and last piece is that I also, because I deal with a lot of device technology, I run a lot of Z-Wave. Everything I have is Z-Wave. I have Z-Wave libraries and controllers and things that work in TSL and whatnot. And I also tend to run power, Ethernet, over all my power in my whole yard, house, etc. So I can plug any device into a power outlet and get Ethernet just from the power plug. And in my cloud environment, I have 70 terabytes of NAS storage. I probably have 20 computers, 200 and some devices, and I run all these different OSs. But I'm not really that crazy and alone in that story. If you actually look at what happened, and we discovered this, I discovered it before I left Microsoft. I certainly deal with it all the time. In a typical home, smart devices are anything but smart when it comes to their network communication. They're trying to make it really easy for you to connect up, but what they actually do is they create a horrible storm in your network cloud. And oftentimes, They can make your network very slow. They can cause your network to crash. They can compete with each other, and they're completely insecure. On the other hand, it's one of the fastest growing areas. Gartner numbers from just recently, 8.4 billion connected devices will be in use very soon. This is growing at an incredible rate, and the need to program these devices and deal with them is also growing. And the reason for why this is tied to the DevOps track is what we had to deal with in the public cloud and running servers and systems was a very complex process of being able to manage many machines, configure them, track telemetry, monitor, etc. It doesn't look actually any different as you start to move to the private cloud or even the personal cloud in the home. And so you need to get to a model where people can both manage it, you can deploy software for it, but also where it's almost DevOps free. Otherwise, the IoT market and devices can't even be successful if the consumer can't use it reliably. So I was going to go here and show some things about the desktop and explore files, but I think the demo might be a little distracting. I want to do it after I talk a little more. So first I want to talk about some concepts. One of the things that every package or application has to deal with is, every piece of software has to deal with is how it's packaged, how you install it, and how you configure it. So what we're going to do when we do look at the desktop in a minute is I'm going to show you how I put together the demo system that we've been running and how it's packaged. But the important concepts to take away from that model are, one, everything's got an AF name at the front. There's a number of reasons which I was jokingly alluding to at the very first talk I did, which is it's at the top. Dot files tend to be ones that are automatically invisible where you don't really need to care about it. Everything that is part of an installation will live in a .af folder, which then is owned by the system in terms of what its layout. You can do anything you want with the rest of your directories. And then AFWS is basically the same as a fossil checkout file. It's just my name for it. And AFR is the same as a fossil repository of some kind. And the difference between the AFX and the AFR extension is only that the AFX extension is registered to be automatically run like a script and execute. Now, on the last part is, which I promised Richard I would talk a little bit about, are symlinks. So I'm going to share a little bit. Let me make sure I understand how many people here know what a symlink is. Can I get a show of hands? All right, that's pretty good. So Windows is a little different on symlinks than Linux, for those who aren't familiar. On Linux, first of all, a symlink is always client relative. So it's resolved on the client who's accessing it. What does that mean? If I put a symlink on the server to something, when it's resolved, it's actually going to resolve if I'm accessing that as a mounted drive on the client side of the fence, not the server side. On Windows, they have a distinction. Depending on whether you call it a junction or you call it a symlink, it resolves on one side or the other. What would that mean? If I have a symlink in it that exposed my drive C something or other directory, it's going to be resolved on the client's C drive. But if I have it as a junction, it actually resolves on the server. The client doesn't even know I did it. So it's an invisible symlink redirect. And the way they're really implemented on the Windows NTFS file system are by what are called reparse points, which are in the file system driver. It will actually see that redirect and then choose to resolve it either locally or remotely in the Samba model, for those who understand how Samba works. And reparse points don't have to be files at all. They can be anything. A reparse point is actually an interrupt in the file system resolution path to call a piece of code to decide what to do next. So you can have reparse points mounted to Fuse file systems, Docker file systems, and many other things to registry. Similar to the way the proc model works on Linux, etc., the CDOS. And last of all, to comment on that, when we're talking about a symlink, and you're using it in the context of a repository, whether it's fossil, Git, or something else, maybe you want it to be treated as a file whose type is symlink and just stored in the repository, so that when I uncheck out the repository, the link is restored. And maybe I want the repository to ignore it and treat it like it's just a redirect I've done locally. It's similar to the same problem with client versus host. There are scenarios where you want it to see the symlink, and there are scenarios where you don't. And the typical trick that I use, the way I model this both on Linux and on OS X as well as on Windows, is on Windows, it turns out the way symlinks are built, you can actually separately change the archive bit. And that works very well, and we can discuss why. But on Linux and OS X, you want to set an X attribute and then interrogate that to say how you want the symlink to be treated. And then last of all, I also do for DevOps purposes. Is everybody here familiar with what a DMG or a VHDX is, by show of hands?
You know what a DMG is?
Okay, so a VHDX for all intents and purposes is the same as a VHDX for Windows purposes is the same as a DMG. And they're super efficient. They're very, very performant. I use them all the time. I don't actually install anything on my native systems. I always install them on a DMG or a VHDX and mount them. And I run everything through that. And then I use symlinks to normalize everything, which means when I do an install of a piece of software package, it's always at the same directory path. They never ever change. And I can deploy everything by simply giving you a DMG or a VHDX mount and run. And that means I can move these things to any machine, so my setup times are practically zero, because I can have these things pre-built or I can actually generate them from a script. That's enormous. If you look at a lot of the complexity of installation packages or build systems, it makes all that go away. All right. So now we're going to take a look at some basic. We're going to switch gears. Let me just make sure. Yep. We're going to switch gears and we're going to actually start looking at some live software. That's why I want to finish that talking part. So let's come here. And let's see how well I can do. So first, I'm going to try 14. I'm using a tool that allows me to zoom things up. So hopefully everybody can. Oh, it's still running. Oh, sorry, you're not seeing what I'm seeing. Bear with me a second. I'm going to kill that. There we go. Okay. So as soon as that little HDMI notice goes away, this drive N that I'm on drive N. Drive N is actually, as I said, a mounted VHDX drive. So I can do anything I want with the drive. There's lots of symlinks. I tend to use them as a shortcut for when I'm working on various projects or I'm doing installs. I actually have everything installed under a folder called local. Everything else pretty much is a symlink. In the case of the server that we've been running, I installed it in a folder called .af server. And in here I have a .af folder. In the root of the .af folder I have a comp file. I also have a packages directory. In the packages directory I have an AFX file. I have a folder for libs, which I can use or not use. And I also have sites, which is where all my websites are that I'm going to serve up. And many of my websites, as you can see here, are symlink. So like local.corp.st is symlink to land.corp, N117. A very brief explanation of what's going on here. I happen to own the corp.st domain. And I have a wildcard cert for it, so I can create anything I want, .corp.st. Second, I've hacked my host table on my machine so that local.corp.st is actually going to map to 127.0.0.1 on my machine. So that means I can basically test out accessing any websites I want and give them those certs. The other part is that the server will respond to whether it's to a request with land.corp.st, local.corp.st using the same folder, because they're all actually linked into this folder here called Tcl'2017.corp. So this is where my whole actual website lives. And inside the website, all the demos you've been seeing live as a series of files here. Most of them are marked down. Everything here is checked into the repository. I don't even have to have any of what I've installed here on the file system installed. If I actually go ahead and we come back over here, let's pop up a level and see that that's true. We come in the packages directory. I'm going to open a console window here. If I don't do too many fat fingers, and we'll make this large, and we'll zoom that. And we'll type AFM UI, and we'll go LX. Sorry, AF server here. And we open up the repo, and if we come look at the files, you'll see that in fact everything that's in that repository, everything that you saw me doing is checked in. So the entire site that we've been running and all the things we've been doing don't have to be run from the file system. I can run it with simply that one AFX file and tell the server to launch, and it will serve up the entire project, demos, everything we've been seeing. Is that part clear? Am I going too fast? Does that make sense? The idea is that I don't have to deploy my entire web application and all its websites as anything other than a single database file. That's important because now I can, and more importantly, I can remotely update, check in, and modify my web server without ever having to have anything on the local file system. That's also really important for IoT embedded devices. All right. So I will stop that for the moment. Come back here. So continuing to explore, when this gets run, its true location is sitting in this directory. But I also, because I want it to be able to be executable, I have it defined over here as a symlink in my bin directory. But that's just a symlink to its real location. So now, because I put a symlink in the bin directory, I can just type AF server, as I'm about to do right now. And maybe we'll see the error. Yep. So the first thing to note is it says process cannot access the file because it's being used by another process. This is the Windows quirk. If you try to run an executable as a script, and it's read-write, and it happens to be open for read-write by some other process, it will complain because it's not capable of dealing with that with a script that happens to be open. So we have a helper command called AFX, and then we're going to do the same thing. And now it's complaining that it's already, the port I want to use is already in use, right? So, and all of these things are stuff that, oops, sorry. We're going to take a look at the script that's actually doing this. Oops, did I? I apologize for 1 second. I'm being played by a demo demon. All right. So in here, in the, let me go back to where we were in the previous folder. So going back into AF server, I come into the AF folder and I have a comp file. We're going to take a look at the comp file that actually launches the server when it runs. So this is basically some TSL code in here. And it's running, it's a script that gets run when our whole server is being started up.
6
And
is
let's take a look at
going
the bottom part.
broken.
See what happens at the very end. So at the end of our script, after it's set everything up, it's going to run something called common init. Common init up here is going to run, and it's going to start up our server, log out what happens. It's going to ask if the server's already been initialized. It's going to include some common files we need, like a domain handler and a socket listener. It's going to come in and check out what domains we're authorized to serve. And then it's going to loop and register all those domains. Finally, it's going to ask, is it being run as a worker, or is it being run as the server? And if it's being run as the server, it just doesn't need to do anything else, so it's finished. Sorry, if it's being run as a worker. If it's being run as a server, it's going to set up a few locations to where things live, and it's going to then go into a loop running the IO wait routine, which is basically able to serve up any number of recursive websites or worker threads. This comp file has another couple things that we did at the beginning. Now we happen to be using this as a web server, but in fact, it's also just a command line tool. So the very first thing that happens when it runs is it looks at, let me take a quick start up here. It registers a function called stop server, which has stuff that uses Wimic from the command line right here. And this will be a typical kind of DevOps thing you need to do on Windows. I'm going to run a command. I'm going to run the Wimic command. I'm going to go try to find processes that have my name. And I ask what my executable name is, which I got by looking at the app namespace for the path name, the true path name. Now what a true path name is if you have symlinks and you want to know where they all resolve to, that's the true path name. So resolving all those symlinks to get where it really lives is called its true path. And we want to know where that thing really lives. And then we also want to know what its real name is, because we've symlinked about that executable multiple times, so we want to know which executable is really running so we can terminate it. And then what we do is we run a child process, which we run in blocking mode since we didn't run it asynchronously. and we wait for it to run this wimp command and tell us what processes are running. And then this passes it into find string here. We then go and split those up into the results, and then we walk through there and we build another child process to task kill it. So we literally are saying, what's our name? Then we ask the OS what processes are running with our name and ID. We parse up that result, and then we actually tell the OS to go and kill those processes. This is a very typical kind of command line DevOps thing one might have to do. And that gets run basically at the start of our server. So let me stop there for a moment and say, did that make sense to people how the conf file started up and worked? Okay. So if I come here now to the command line, and I type AF server, oops, 1 second. I'm not sure why, just bear with me. I'm looking for why it thinks that something is true that isn't. So I'm actually looking at process viewer tool. I apologize. Oh, that's what I'm looking for. I don't know why. I wanted to be able to show what happens when I run it without anything. So here it said usage AF server and gave this output. So how did that actually happen? Well, how that happened was, step one, the file was called AF server. It's called AF server, and it had to locate it. So we had so our AFX helper knows how to locate that, doing a file search. Two, once it found it, it then discovered where the comp file was in the AF. So back to here, let's go to here. Once it got in the AF directory, it was located in packages. So once it found this location, it knew that relative to this location, up one level, should be the comp file. It found the comp file, loaded it, and ran it. If it hadn't found it there, it would have looked in the same relative path directly in the repository-based file system. So it would have looked for /:comp.tsl. Inside the comp file that we were seeing there, if I come up to the top, and I collapse the stop server part, here we have a thing that's actually looking at the arguments for the command that were passed on the command line. Now, as a convenience, when the AFM system started up, it processed that command line and so on. It went and looked at those arguments and parsed them up for us, so we can just go and interrogate and say, was the command start, was it stop, was it update, was it info, was it verify, show usage is true, and if it was none of those, just output this on the command line. That was all that happened. So we're able to build executables pretty simply that have any kind of resources in them and deploy them as databases. And I chose this example because this is running the actual web server. There's literally no other code than what I've shown you for the entire web service I've been using to demo and run things, which serves all those websites. I didn't have to do any configuration at all. Well, that's not entirely true. I did one piece of configuration. Let me show you the actual configuration I did for the whole server. So because I wanted to be a web server, I set a couple things of search paths. So I changed some directory locations for where it should actually search for files in the include system. And the second thing I did was I told it where my certs were located. So I gave it the directory location to find certs, which it has a default. I just happen to be not using the default location, so I overrode it and said they're actually at the root of my drive. It has a full cert manager, but these are the certs that I was using to serve the site and so forth. How am I doing on time? Do I have another minute or am I done? A little bit of how the whole thing got booted up. So to do that, I need to come over here, and I need to show you what's actually in the system package. I need to come, oops, it will cooperate. I need to come to kernel. This is actually what boots up. So the other thing about the AFM engine is it has very little in the core that's in C or C++. Almost everything's actually written in TSL. This is the first part that boots up, and it loads everything. So it's called system kernel. There's this at in here. So there's carrots, there's other things you'll learn about in the language. At's a module. Modules mean that I get to actually share its context and register objects within it. I registered on the subsystem event function. I set up a bunch of namespaces. A namespace is just an object, but there's a feature called minting, which we're not going to talk about in this talk. We'll talk about in the next one. And then finally, after I get through all that, it comes to the end. It set up all this registry stuff. You can read the registry, and then it invokes this function, which right here goes and says, load these core libraries, ANSI, trace, proc, a few other things, include this, and then finally execute the command line. And the execute command line is basically just looking for a function that's defined that's equal to the name of my exe. So if my exe was named AFX, it's going to run the one called AFX. So I want to just find that one piece and then we're done. So here I have a function called AFTS. So if my executable is called AFTS.exe, this function is what gets invoked. That's all that's going to happen. It's going to boot through that kernel code and end up right at this function. If it wasn't called AFTS, it's got these other aliases. AFTR is just an alias to it. So the and is essentially an upvar. It's just a shorthand for doing an upvar. And here I've got AFTD registered. Here's where the AFX proc lives. So AFX is in here, and I happen to have the conf loader for it. That's what loads. This is what's actually searching for that .conf file and loading it for us. This is the search pass it's looking at and setting up some things about our environment. And this is the actual AFX routine, which just checks to see some things about whether or not it's quoted and whatnot. And then finally, here's the stuff that does the AFM and runs it, which also just falls back into the default fossil execution if it doesn't have any special parameters. That's the core of being able to build binaries, executables, etc. The rest is a core. It's just a Tcl' TSL engine that loads in and runs and allows you to do whatever you want to do to build an app from a single binary. So that concludes, I think, my talk. Let me just quickly go back to the slides and come to the closing slide. We talked about customizing the system. You saw that in the demo. We talked a little bit about reflecting on the system. I didn't talk too much about the binary build model in here, but I think I did in the previous talk, so I'm not going to repeat it since everybody's in the same room. And that's the end of the talk.
Okay.